So is it true that you named your company Zero Gravity because the token will never dump and it will just go up? I mean, I read it somewhere. Sources, trust me, bro.
That's a terrible promise to end users. The token will never dump. Yeah, that sounds like a Ponzi right there. Yeah, so we're building the most performant, most secure, and also most programmable/customizable DA layer. How we came to this journey is that we fundamentally believe that if you want high performance applications on the blockchain, how can you do that without high performance data? And today it costs, like 60 plus million to store a gigabyte on Ethereum.
Right.
So how can something like Onchain AI become a reality with something like that? Because you need the models, you need to store the models, you need to serve as inference traces. And so that was really the thought path that we took, is let's make this a reality. The mission of our company is to make AI a public good, and you can only do that with high performance data.
Right. And like, how are you tackling this issue? Like, let's dive into like the specifics of it.
Yeah. So the key thing is performance originally. So what we do is we hyper optimize on a per node level what the performance is that we can get out. And so we expect we've tested somewhere on the 10 to 20 megabytes per second per node. And then we have an aspect of horizontal scaling that we add to that. And so instead of propagating data to all nodes, we propagate erasure-coded data chunks to a few nodes on our storage network. And then we have a consensus layer that then does data availability sampling, and then basically says like, okay, this actually exists. We have a consensus, and then we do KZG commits to then be attestable to Ethereum as well.
Got it. Yeah. So like you mentioned that it's the most customizable and programmable DA, right? Like, what all things can be customized? What all things can we change and play around with?
Yeah, so we started it from a first principles perspective. So we have a fully formed storage network. So you can customize anything about the data, where it's stored, how long it persists, how much replication you want. And then the other thing you can do is you can actually dump your entire state into a smart contract and then load it again at a later point. So you can like solve the state bloat issue that way.
Right.
And so that's the programmability aspect that's really like cool and critical.
Got it. Yeah. So yeah, how did you come across the name Zero Gravity?
No, it's actually, so it comes from this idea of, to us, infrastructure should actually be invisible. Like, nobody wakes up in the morning and says like, oh, I really love using this bridge, or I really love like being exposed to many chains and doing X, Y, and Z. And so we said, how do we build something where it's like really enjoyable to use and you don't even know that it's there?
Right.
So to us, that's what we wanted to build fundamentally from an infrastructure standpoint. And that's why we said zero gravity implies a sense of weightlessness.
I'm actually really curious to understand how Onchain AI comes into this picture, and like, what are your plans for Onchain AI? Because until now, it's always like, oh, Web3 is a buzzword. You throw in Web3, you raise money. You throw in AI, you raise money. And like now it's the combination of both that people are playing around. But this is like some serious stuff that we're talking about, right? Like, if you could explain it to us, like, what is this? What is Onchain AI?
Yes. Right now it comes in two flavors. So there's ZKML and then there's OPML. So ZKML, you're basically proving that you've run some type of ML algorithm, some form of data. And the challenge there is that you can prove that you've done this successfully, but you can't prove that the data you use wasn't tampered with. And so the easiest thing to do there is actually put all the data on chain. So let's say you're running something on top of Twitter API data. Okay, great, put that on chain. OPML is a little bit different. It allows you to actually run bigger models on chain and efficiently enough. And so what you need to do there is basically store the entire model first on chain, and then you also serve the inference traces. And so if you have millions of concurrent users and each one of those inference traces is like 100 kilobytes and you have a request per minute, all of a sudden you have multiple gigabytes per second in terms of DA needs to service that. And so those are kind of the basics of how it works. But let's go back into, why do you even need on-chain AI? Like, why does this matter? Why can't you just use ChatGPT?
Right.
Well, what if you want to know what is the model that's actually running things? What are the weights that this model has? How do I know it's making the right decisions? So without a blockchain setup, that's really difficult to do, especially if you imagine that you have hyper intelligent AI agents in the future that can change their tracks in a centralized database, for example, and lie to you. So I was thinking about this morning. Like, here's a simple example. Let's say five years from now, you have an Android that's doing your, ordering for your refrigerator, and you have 4 people in the villa that are sharing this. And the Android says, like, it costs me $100 to put this order, and then collects 25 from each person. What if the Android keeps withholding $20 for him or herself, and just consistently gets more and more cash this way, and then eventually, does something with that cash that's very nefarious?
Right.
In a centralized way, it could easily hide that, because it could just say, like, okay, well, here's the transcript of stuff that I bought. In a decentralized way, if it's actually placing that order somewhere, you see the entire order log, and you have a complete alignment around what the Android says it does and what it actually does.
Right.
And so you have a governance aspect to having an on-chain AI agent that way.
Wow, that's beautiful. Like, we guys stay in a villa. I think I'll download that app like right now.
Not quite ready yet, but in the future. And so this is a simple example, but imagine you have AI agents that start running traffic control systems, that start running manufacturing processes, administrative processes. Like, you could imagine ERP systems being an AI agent in the future.
Right.
Like, how do you make sure that those AI agents are actually doing what they say they're doing?
Right.
And that they're making decisions for the best of humanity's interests. And so that's what we want to see as a future.
Correct. Yeah.
AI for human good.
Yeah. I don't want to fight any AI right now. So yeah, I mean, data availability has always been like, it's been a while since it's been the talk of the town, right?
Yeah.
You have Celestia, you have Eigenlayer, you have Avail, right? And now you guys are bringing data availability 2.0.
Yes.
How are these things different? And like, do you think like the kind of technology that you're working on, how can these guys like catch up onto that? And how, if yes, like what would be the time frame, or what is the moat right now for you guys?
Yeah, so you'd have to completely re-architect a lot of those systems that are out there to kind of match the performance requirements and needs that we've been able to do. It's fundamentally different architectures, basically. So, for example, in Celestia Avail case, they propagate data to all of their nodes simultaneously. So there's no aspect of horizontal scaling, for example. So the slowest node in the network dictates network speeds, for example. They also don't have a fully formed storage network, so it's then, somebody that's building AI apps has to then use another service and then cobble things together. So the technology architecture itself is a huge advantage from that perspective. The other thing is that you don't give up Ethereum level security by working with zero gravity, because essentially we're testable to Ethereum, which is something that you have to do in other cases. Or in EigenDA's case, you're essentially having the restaking nodes choose to stake into you, and there's a majority secure assumption as part of that, and so it's not true level Ethereum security as well.
Got it. Yeah. You were kind enough to share the deck with me, and I was going through it last night, and like your team slide is like a killer ass team, right? Like, how did you bring all these giga brains together? You guys have like published a few research papers as well together, and then like based all your research on that, right? Like, how did these Avengers assemble? How did this happen?
The call to action happened, and they came in, Justice League Unite. So my classmate from Stanford, Thomas, that I've known now for 10 years or so,
right?
He was an early investor into a company called Conflux, and basically has known Ming and Fan for like 5+ years. And so he knew I wanted to start something on Web3.
Right.
And was like, hey, Ming and Fan want to do something more on a global scale. Are you interested in chatting with them? And I said, like, I've been waiting for something like this. Why didn't you tell me earlier? And said, like, of course, let's get together. And so just spend, many months of co-founder dating with Ming and Fan. And after that, I was just super convinced these are the best technologists I've ever worked with. Ming is like 11 years at Microsoft Research, like an AI and distributed systems and storage expert, written a lot of the key papers in the space. And then Fun, he holds like 2 Olympic gold medals in informatics because of him. I think the Chinese government actually says you can only go once to informatics Olympics, which is pretty funny. And then MIT PhD and like University of Toronto professor. So both phenomenal technologists. Love working with them. And so I really thank, my friend Thomas for bringing us together. And Thomas himself is a really smart, really sharp investor and very keen on identifying talent. And so like his insight really helped bring us together.
Sweet. Okay, where should we start?
Yeah, he's just here in the torch, I think.
Oh, awesome. Oh, that's him.
Oh, yeah. Ming! Ming!
Wait, I'll just get down. What's up? Come here, sit here. I'll sit in the front. Yeah. How are you? Good morning.